Hi everyone, in this video we're going to cover the following topics. If they are familiar to you, please skip the video to the questions, answer them, put your answer in the comments section below. If they are not, just join my class. Hi everyone, welcome again to my class. In this video we're going to continue talking about Lewis structure. My advice for you is that if you didn't watch the first part, please hit the first link in the description, watch that part, and then continue this one. And by the way, don't forget to subscribe to stay tuned. And let me start by polyatomic ions. If you want to draw the Lewis structure for polyatomic ions, we are going to follow the same steps that we followed with molecules, but here we have to be careful for the charge, which will affect the valence electrons. If it is positive, then we have to deduct from the valence electrons. If it's negative, then we have to add to the valence electrons. Like here, if you want to draw the Lewis structure for ammonium and H4+, we have to follow the same steps that we followed with molecules. We have to draw the Lewis structure for all the atoms. Here we have 1 nitrogen with 5 dots, 4 hydrogens each with 1 dot. Then we count the valence electrons. We have 9 valence electrons, but since it's a positive ion, we have to deduct 1 electron from the total, so we are going to have 8 valence electrons, not 9. Then we place nitrogen at the center with 4 hydrogens around it. We put the shared pairs of electrons between every 2 atoms. Now we verify that all atoms are stable. Nitrogen, it has complete octet with 8 electrons. All hydrogens are stable since they have complete duets. We count the number of electrons. Here we have 8, which is equal to the total number of valence electrons we counted at the top. Then we put it in a parentheses with a charge +1. And the last step is to change the shared pairs into long dashes. And don't forget the parentheses since it's a polyatomic ion with a charge. Another example, sulfate SO4 2-. Sulfur is in group 16 with 6 dots around it. Oxygen also in its group 16 with 6 dots around it. We draw the Lewis structure for all the atoms. We count the total number of dots. Here we have 30 dots. But since sulfate it has a charge -2, we have to add 2 more electrons to the valence electrons. So we have 32 valence electrons. We place sulfur at the center and oxygens around it. Then we add the shared pairs of electrons between every 2 atoms. We complete the octet for oxygen atoms. And now we add the total number of dots, which is equal to 32. And all the atoms are satisfying their octet. Don't forget to add the parentheses with the charge. And the last step is to change the shared pairs into long dashes and also to add the parentheses with the charge. And now, before I move to something else, I will give you the chance to practice drawing Lewis structure for a polyatomic ion. Please pause the video, try to draw the Lewis structure for this one, and then play the video again to check if your answer is true or not. And now let's start drawing Lewis structures with multiple bonds. If we want to draw the Lewis structure for oxygen molecule, here we have 2 atoms of oxygen, each has 6 dots, so the total number of valence electrons is going to be 12. When we place the oxygen atoms next to each other, and then we add 1 pair of shared electrons in between, and then try to complete their octet, we don't have enough electrons to complete the octet for both atoms. Either we complete the octet for the left atom or for the right atom. So the only way to complete their octet is by sharing 2 pairs of electrons. And then we complete the octet for both atoms and we count the total number of dots. Here we have 12, the same like the total number of valence electrons. And then we change the shared pairs into dashes. Here we have double covalent bond. Another example, methanol with formula CH2O. We draw the Lewis structure for all the atoms. Carbon with 4 dots, 2 hydrogens each with 1 dot, oxygen with 6 dots. We count the total number of valence electrons. Here we have 12. We place carbon at the center with the atoms around it. We place the shared pairs of electrons. And now if we want to complete the octet for carbon and oxygen, we don't have enough electrons, since if carbon completes its octet, we still have 4 more electrons which are not going to complete the octet for oxygen. The only way to complete the octet for both of them is by sharing 2 pairs of electrons between carbon and oxygen. And by counting the number of dots, here we have 12, which is equal to the number of valence electrons. We move to the last step, which is changing the shared pairs into dashes. Let's have some examples where atoms may share up to 3 pairs of electrons. Like here, nitrogen molecule, if we draw the Lewis structure for nitrogen atoms, each with 5 dots, the total number of valence electrons is going to be 10. If we place 1 pair of shared electrons and then try to complete the octet for both of them, it's not possible. The only way to complete their octet is by sharing 3 pairs of electrons, and then we have triple covalent bond. I will do one more example, then I will give you the chance to practice. Here we have hydrogen cyanide. We draw the Lewis structures for all the atoms. Number of valence electrons is 10. We cannot complete the octet except by sharing 3 pairs of electrons between nitrogen and carbon, and then we change the shared pairs into long dashes. Now it's your chance to practice Lewis structure with multiple bonds. Pause the video, try to draw the structure, then play the video again to check your answer if it's true or not. In this part of the video, I'm going to show you a few exceptions where elements can be stable without having a complete octet. Such exceptions like boron in group 13, tin in group 14, and beryllium in group 2. These elements, they don't complete their octet while doing covalent compounds. Like here, if we want to draw the Lewis structure for BH3, we start with B with 3 dots, 3 hydrogens each with 1 dot. The total valence electrons is going to be 6. So when we place boron with the 3 H's around it, boron will not have a complete octet and it's going to be stable like this. The last step, we change the shared pairs into long dashes. Another example, tin dichloride. We draw the Lewis structure for tin with 4 dots, 2 chlorine atoms each with 7 dots. The total number of valence electrons is going to be 18. 10 at the center, chlorine atoms at the ends. First we place the shared pairs, then we complete the octet for chlorine atoms. We don't have enough electrons to complete the octet for 10, and it's going to be stable like this. By the way, always when we try to complete the octet, we start with the more electronegative elements. Don't forget that I kept a link in the description to show you how to arrange elements according to their electronegativity. And the last step, to change the shared pairs into dashes. And now it's your turn to draw the Lewis structure for beryllium difluoride. And this is the last part of the video where I'm going to talk about resonance structures, which is the case when we have 2 or more possible structures for the same formula. Like here, if you want to draw the Lewis structure for ozone molecule with the 3 oxygens, first we draw the Lewis structure for oxygen atoms, each with 6 dots. The total number of valence electrons is going to be 18. Then we place the oxygen atoms next to each other, and in between every 2 atoms we place 1 pair of shared electrons. And then we find that we don't have enough electrons to complete the octet for all the atoms, so we have to share 2 pairs of electrons. And here we have 2 cases. Either the central atom shares 2 pairs with the right atom, or it shares 2 pairs with the left atom. And since both are true, we have to draw them both, and then we draw a double-headed arrow in between. Another example, nitrite ion, NO2-. Here we have one nitrogen atom with 5 dots, 2 oxygen atoms each with 6 dots. The total number of valence electrons is going to be 17, but since it's a polyatomic ion with a charge -1, we have to add one more electron to the total number of valence electrons. So here we have 18 valence electrons. We place nitrogen at the center with oxygens around it, and then we put one shared pair of electrons in between every 2 atoms. We complete the octet for oxygens, and we find that we don't have enough electrons to complete the octet for nitrogen. So here we should share one more pair of electrons. We have 2 cases. Either the nitrogen shares 2 pairs of electrons with the left atom, and we draw it like this, don't forget the parentheses with the charge, or the nitrogen shares 2 pairs of electrons with the right atom like this, with the parentheses and the charge. And don't forget to add the double-headed arrow to show that these 2 structures are the same. The final step, we change the shared pairs into long dashes, we put the parentheses with the charges, and we add the double-headed arrow in between to show that these are resonance structures for the same formula. And now, do you know what we mean by VSEPR? Stay tuned, since this is the topic for the next video. And now you are ready to solve the end of video questions. Please, if you are not, repeat the video again. Otherwise, solve the questions, put your answer in the comment section. If you have any question that I didn't cover in the video, please share it with me in the comment section. Share this video with your friends. Subscribe to my channel to stay tuned for more videos. See you in other videos, and good luck.